a quick video just to talk about our first performance task. I'm going to talk through all of the information here and show you a couple other little things, and then I will show you where it is on Blackboard, and that's it. So as I talked about, I think on the first day when we talked about the syllabus, this performance task has two portions. So the performance task is made up of a written portion where you're going to do some of your own creation of equations or matrices or things like that, and then you're going to use those creations to complete the problems. The second portion of the task is an oral portion. So in the past I've done it as a video portion. We're going to do it live instead as more of a conversation and less of a you just talking to yourself. Hopefully that sort of helps out both of us in a couple ways. You in the explanation process, me in the grading process. So once you've submitted your portion, or if you already know when you kind of want to talk about or when you have some time to schedule the oral portion, you'll schedule a time with me. I have a schedule of times that are available already up, so you'll schedule within there unless you can't find a time that works, and then we'll talk about that. But this is your assessment. So this is like an exam. I need you to treat this with academic honesty and academic integrity, which means that I want to know what you know. I don't want to know what the internet knows. I don't want to know what your classmates know. I don't want to know what Tom down the street knows. I want to know what you know and what you understand. And so what I will allow you to use for this, anything that's on Blackboard, anything that I've provided you, anything on OneNote, you are more than welcome to use as either inspiration or to help you with your thinking. That is perfectly fine. Things that are not acceptable to go Google something, or to use calculators for something that I don't ask you to use calculator for. So for example, so far we've been doing a lot of matrix operations, and yes, I am very aware that there are a billion calculators out there that can do matrix operations for you, but I want to see what you know how to do. So what I ask here is for the written portion, I want to see all of the work. I want to see the process. I don't just want to see an answer. I don't actually care about the answer, I'll be honest. I mean, I do care in the fact that a lot of you are going to be engineers and things like that, and so the final answer is fairly important, and the correctness of it is also fairly important. But the process and the way to get there is about 90% of what I'm really interested in. So again, you're going to be graded for this both on completion and correctness. So this is not like your practice assignments where I'm just looking for you to have tried it and tried your best. I am looking for you to have tried it and shown some proficiency with this. The oral portion is also a required portion of this task. If you fail to make an appointment for the oral portion, or you do not show up for your appointment, or something happens and you just kind of blow it off, that will result in an automatic 0 for the entire task, regardless of how much effort or how correct your written portion is. So that is a very, very important piece of this. You need to have both pieces satisfied in order to get a grade for this. You have 5 days to do this, so the task is up now. You have until Friday at midnight to submit the written portion. You still have some time after that to sort of think about the questions, and I'll show you a little bit more about that. But the written portion and the actual physical work is due Friday at midnight, and will actually be submitted on Blackboard this time, not on OneNote. Blackboard does a timestamp, and OneNote does not. So that's that. So that's sort of the general information. So what I've done is each of the portions, so there's written parts are separated into sort of themes here. So each part has its own directions. And then I've put all of the things to think about, or things that I might ask you and that I'm probably going to ask you about for the oral portion at the end of this particular document. So the first part is all about our systems of equations. So the first thing you're going to do is you're going to create 3 different systems. So that means 3 individual systems, not a single, not 3 equations. This is technically you'll have 9 equations. Each system has to have one of these properties. One needs to have just a unique solution, one needs to have an infinite number of solutions, one needs to have no solutions. And then just to make things fun. Make sure that that you don't have more than 2 zeros for any of the coefficients on any of the variables in your systems at any point in time. That also means that you can't have this equal to the 0 matrix or anything like that. So a little bit of restriction there. And then what you're going to do is you're going to use those systems that you created to show me basically how you know that those things are either what kind of solution they have. So questions 2 through 6 use the systems that you created here to answer these questions. So you'll use your system with one unique solution to show me 2 different methods for finding that solution. You'll use your infinite solutions to show me the row reduction method for finding the solution here. Then you're going to write your solution to your system for the infinite one in multiple forms. And then you're going to look at just the coefficient matrix for all 3 of your systems and determine the linearity, or determine whether it's independent or dependent. And then for any of them that are dependent, you're going to give me a linear dependence relation. So just one of them. So that's all on systems of equations. For matrix operations, so part 2, matrix operations, you're just going to make 4 matrices. And again, there's some rules here to follow. You need to have at least one matrix that is a square matrix that is at least 3 by 3, could be bigger if you want, but needs to be at least 3 by 3. None of them can be a vector. Hopefully you know what that means, what the distinction is between a matrix and a vector. 2 of your matrices need to be of the exact same size. It doesn't, and I don't care which ones, but 2 of them have to be the exact same size, and 1 of them needs to be a rectangular matrix. And then again, you can have at most 2 0 entries in each matrix. So most of them need to be numbers. And then you're going to do some operations with those matrices. You're going to find each of these relationships, or each of these relations or expressions, or explain why you can't find them. Then you're going to find the transpose of each of your matrices, and then use that transpose to find the product of itself and the transpose. Then we're going to go pick one of your, so it's possible that you might have more than one square matrix. That's perfectly fine. But pick one of your square matrices that it's at least a 3 by 3 matrix, and determine if it's invertible, and use the invertible matrix theorem, the IMT, to justify whether or not it's invertible. Then you're going to actually invert that matrix. If it is not invertible, so if you find in 4 that it's not invertible, take that matrix and modify 1 or 2 of the entries. So keep most of it the same, but modify just as little as possible to make it that it is invertible, and then find its inverse. And then you're going to show me that you actually do indeed have an inverse. So you need to understand what it means to be an inverse and how do you justify that. Question 7 and question 8 do not involve the 4 matrices that you created earlier. In question 7, you're going to create a 5th matrix. You're going to call it B, and it's only a 2 by 2 matrix. And you're going to use it to solve this matrix equation. And then the last one, I've given you a matrix K, and I want you to find 2 matrices that would make it so that the products of K and those matrices are equivalent, but that those 2 matrices are not equivalent. And the last part here for the written portion is about linear transformations. So for linear transformations, again, you need to create a matrix here, and I've given you need to come up with numbers here such that the determinant comes out to be 7, and only one of these things can be a 1, and none of them can be a 0. So a little bit of I'm just going to throw that one out there for you, so a little bit of fun there. And then you're going to use your linear transformation. I want you to prove to me that using this A, what do you need to show in order to show that this is a linear transformation? And then I've given you 2 vectors here. I want you to find T of U, T of V, and then determine if either of those things would be in the range of the transformation. So I'm not going to tell you what that means because that's part of the question. And lastly, I want you to find some vector whose image under that transformation is the 0 vector, and what does that mean about the columns of A. So those are all the written portions, and those are what you will need to turn in on Blackboard. And I want to see all of your work, every little thing. If you're It doesn't have to be perfect and polished, but yeah. Now, for the actual submitting portion of this, I do ask that you use a template that I'm giving you. So this is what the template looks like. You are more than welcome to type in here, but I completely understand that it is not great to show your work and show your process through the typing process. So however you want to make sure that you show me your work, so just like we do in OneNote, if you want to do all the work out by hand and just take the portions of it, the pictures of it, and put that where I ask you to so that I know where to look, that would be spectacular. The reason I do this is that it helps keep me organized so I know where to look for everything, and I'm not looking for the answer to part 1, question 1 on page 6 of your work, right? So this keeps it all organized and in the right places and makes it easier for me to find the information and then find the work that supports it. So again, you don't have to type in here. If you would like to type in here, so for these matrices, if you would like to fill this in and type these in, these are already equations. If you type in here, if you go to the equation editor up here and go to matrix, you'll see these are different sized matrices you can create if you just type in the brackets. Using my keyboard, I'm just typing in the bracket here, and if I put in the matrix, I don't know, let's do a 2x3 matrix, and then I close that bracket. If I hit space after the fact, you'll see it gets nice, and then I can go in and click in each of these places and fill that in. But you don't have to. If you would rather write this out on a piece of paper and put the picture of your matrices right underneath this, and so that very clearly I can see what your matrices are, that is perfectly fine with me. So hopefully that makes sense. Again, same thing here, showing me all your work. If you would like to just put pictures of that, perfectly fine. So this is the template that I'm going to ask you to use. If at all possible, if you could upload this after the fact as a PDF, that would be great, but not necessary. The other thing that I'm going to ask is when you put in your pictures of your work, if you're putting pictures in here, please don't resize them. Let them be as big as they want to be, because it's a lot easier for me to resize them and make them smaller than it is if you make them too small. I can't make them bigger to be able to see. So make sure that they're big enough that I can read the work and I can follow the work, but don't make them so small I can't see everything. So don't worry about resizing anything. I will do that if I need to. All right, so that's the template. So I'm going to go back to these guidelines and talk about the oral portion. So for the oral portion, I've separated this out into the 3 parts. And so each of the parts, right, has a different focus. So each of these are questions that I'm probably going to ask you or we're going to talk about during your oral portion. Things like how you created your system. So these are all things you should be able to talk about and be able to explain as we're having the conversation during our oral portion. Each oral portion is scheduled for 20 minutes. There's a little bit of wiggle room if you need a little bit of extra time. That's perfectly fine too. But 20 minutes should be plenty for us to have these conversations. So these are sort of your guiding questions or things that you need to be able to talk about when we have that when we have our meeting, our individual meeting. But you don't have to physically do anything with these questions. So they're there for you to think about, for you to have as sort of I know what I'm going to talk about. Yeah, so I may ask some follow-up questions as I ask you these things. I might ask you to sort of give me a little bit more, or give me, like if you give me an answer, I might ask you to give me a little bit more information about that or something like that. Basically, this is just my way of getting real deep into your understanding and your thinking of your process and what you did. All right. The last thing that you will find on Blackboard is the grade sheet. You do not need to do anything with this. This is for your information only. On the grade sheet, you'll see there's a written portion, there's an oral portion. Ignore these numbers right now. I have not edited them. They need to be shifted and changed. But this basically just tells you, have you done all of these things? Here's the points for them. Great. And so when you get your grade back, I will give you the sheet that looks like this with If all your systems have 3 variables, I'll put a check mark here. You'll get your 1 point. Ta-da! Anything that's not quite correct, so if I'm looking for correctness and maybe there's an error somewhere, I will give you feedback, or I'll write in here what that error was or where I saw something go wrong. I also am aware that any mistakes originally, so if you have trouble with creating your functions, your equations, your matrices, that could influence things as you go along and do the things with them. But just because you don't necessarily have the right qualifications for a matrix or whatever, if you do the rest of the processes correctly for the equations that you have, I'm not going to penalize you for the rest of the processes. Hope that makes sense. So partial credit. I'm all about partial credit. Again, I'm just looking for what you understand here and what you're able to do with our matrices. So I'm going to show you real quick what Blackboard's doing right now. So if we go to our, here, we'll enter student preview mode just for fun. So under course materials, you will see under week 2, there is this performance task 1. Again, it's telling you when it's due. Once you've submitted your written portion, sign up for your oral portion. Make sure, so the oral portion, the times there, you're just going to click on the class link for the class Zoom link. We're going to use that exact same link for the performance task part, but it'll just be you and me instead of me and all of you. Anyway. If you aren't able to make any of the times that I have proposed, please send me an email to let me know at least 2 other times that would work better for you, and I'll check my schedule and tell you which one is better for me. All right, so under the performance task 1, you will see the first thing here is the guidelines. The guidelines are right here. That's what I just showed you, the written stuff there. I will also post the, like I said, I need to edit oh, my brain just went exactly just like that. The grading sheet. I will edit the grade sheet, and then I will actually attach that right here, so it'll be under here. To actually submit, you're going to click on this performance task 1 here, and you're going to browse your local files. You're going to find the one that you have named using your first and last name. If you can do this as a PDF, that's even better, but if not, that's okay. A docx is perfectly fine as well. So you'll browse there. If you have any other files that you need to submit with it, just make sure that you attach all of them at once, and then you'll hit your submit button here. Now, I do give you 2 submissions just in case you forget something or you realize you made some mistake somewhere. You have the opportunity to submit a second time without having to email me or let me know. The last thing that you're going to do is this is a link to the sign-up sheet. So if you click on this link right here, it's going to open up a Google Doc here that you should be able to write in. And all you need to do is take a look here, and for whatever time you decide that you would like to come meet with me, you're just going to put your name next to it. So just to show you what that would look like, I'm going to put my name next to 11/25 on Tuesday of next week. So not this week. I want you to get everything done first, and then, right, you got till Friday. So put your name there. Please don't erase anybody else's name. If the time is taken, sorry, they got here first. Also, like I said, if you do not see a time that works for you anywhere on this list, email me and let me know. Propose a couple of dates and times that would work for you. We'll find something that works. If you make sure that you jot down what time and day you're supposed to come meet with me so that you show up. And again, if you fail to show up for this or you don't schedule it, automatic 0 for the whole performance task. If something comes up or you have something, again, if something comes up, just email me. The more you can stay in communication with me, the better. All right. That should be it for the performance task. Good luck, and you're going to do great. How do I stop this? Aha, found it.